possibilities
Hmm.
of the zombies versus humans. So I think he kind of grouped them on different sides of the screen, and then he had the machine work out all the different possibilities for where all the groups would move,
Right.
and so the zombies would work them out in their favor, and the humans would work them out in their favor, and then it would play out it would then graphically illustrate which was the best um, version, I guess.
Yeah. I did see that channel. I was thinking about, but I was like, I don't even have time for Python. For me to get involved in something else, it's like,
Yeah, I mean, I wouldn't know the first thing about implementing that, but I thought it was interesting the method that they used to solve it. I mean,
That sounds
implementing
like
it.
a lot of code to write, though.
Yeah.
it might not be. There's a lot of, I guess, probably things that abstract it. It's just kind of understanding the concepts and being able to use it, you know?
Yeah.
So,
I think one of the things about it was that the AI didn't really understand zombies versus humans per se.
hmm
Did get far away from those pieces. Let's try every permutation and find out how we can reduce that number or make that number bigger, depending on which side they were on. And then it would just choose the path that was optimal, which was it's not really the way humans think, but it was interesting.
yeah. I've seen some stuff where like they've programmed it to beat Mario Brothers. So
Yeah,
and like really fast. So cool stuff.
yeah,
I gotta get the basics down first.
definitely. I I was just on the Slack channel earlier, and Kenneth Love was showing me some stuff on there. I don't know if you saw it, just with scoping and callable classes, where you can create a class that you can call like a function.
I saw
It,
like the part of that, but I wasn't paying attention to it. But yeah, it looked like it was kind of interesting.
yeah, it was cool. It was here. I can bring it up real quick. Just give me a second. This one. So like he made this class power, and he set the dunder init and dunder call methods on it. And so the init, when it gets created, it just sets the power,
hmm
and then the call method will take a number and return. So like if the power is 2, it'll return that number squared. If it's the number's 3, it'll return that number cubed. So you can see here he's doing that.
So every time you call power, the call runs automatically, just like the init would run.
Kind of, yeah. I mean, so like he creates this power object with a 2, and it's squared, and power cube is a cubed, and then yeah, like you said, you call it, and it does it. It doesn't really work, I guess, the way we're used to seeing objects work, but it's interesting.
I guess the call dunder function, it's the num is what the attribute is passing.
Exactly, that's right here. You're right. You're right. So
Hmm.
this is responding to call, and this is responding to init. So these are the init, and these ones here are the call, like you said. So you're calling that class or that object, and it's performing this here.
Huh. I'm still. Oh, okay, I got it. So you're kind of defining the function that will be called as you initialize it.
Exactly, that's this one here.
Man, yeah.
And that's being done here, like you said. And then you take that object and you call it, which isn't something you normally do. right? You wouldn't say object open parens and pass it an argument. But in this case, apparently in Python you can using this call method, or this call method here. So if you call an instance, it'll
Yeah, you would think it would be square.call.
yeah. But I would think there's some special cases where you'd use that, but probably not very often.
Yeah.
Oh, where am I? Here, this one.
Oh.
So yeah, that was cool.
Yeah, that's pretty cool.
I don't know if you had a chance to look at the the new Code Newbie challenges out there. The ROT 13. It's got a couple different levels, so we took it this time so that you could do it at the level that you wanted to, that you have the time for. Just a basic decoder for a beginner, and then more advanced. If you do have time, I know it's the holiday week. We got Thanksgiving coming up, so everyone's busy. But if you wanted to take a look at that, you can see it out on Code Newbie Discourse.
I looked at it. Are all levels ROT 13? Because okay, I didn't really look that far. I was just saying, hey, if I implemented it, I would probably just do like a dictionary and do it brute force that way. But I didn't realize all of it was ROT 13.
Okay, yeah. Yeah, and that's how it's set up, is that if you want to do it as a brute force dictionary, you can just do that, which is cool. Hey, Jonathan, how's it going? How are you feeling?
Hey, what's up? Not too bad.
Cool. Good to hear. Did you use some Java or Python or C or something to take some DayQuil?
No.
That was funny earlier.
Yeah.
All right. So we were just talking about kind of what we've been up to and what some of the zombie alert solutions that were in the other groups. I talked a little about RubyConf, but I've been avoiding that topic because I think I oversaturated the Python Thursday channel this week with it. Yeah, have you been working on anything this week?
I just did that Codebreaker challenge.
Oh, nice.
I did that. I used the the MakeTrans instead of for loops and all this other stuff, because then you got to check you got to use that ORD function to find the ASCII code number, and MakeTrans was just so much easier.
Do you want to walk through that real quick?
Yeah, I can walk through it.
Okay, cool.
Let's see. You just want me to talk about it or show it, or?
If you want to screen share, you can, or I can bring it up. Whatever's easier.
I'll screen share. Let's see. Oops. And all right. Yeah. All right. So this is the code for the code breaker. You had to. There were 3 different levels, I believe. The first one was to write code that decodes this, and well, I don't know what were the second 2. Then it was to be able to encode these, and then to make sure you could do capital or lowercase. So what I did was I used the MakeTrans function, so you could just put what all the letters are going to be that you want to decode and how they compare to the regular alphabet. So it's like so it like makes a table that Python could just call back to translate everything instead of having to write like, a for loop and then if statements, and you just do that.
So is it kind of like a shortcut to a hash where like N would translate to A?
Yeah, so like when I submitted my code, a guy had submitted it in JavaScript.
Mm-hmm.
And the way he did it in JavaScript was the same way you would have to do it in pretty much every language if the MakeTrans function doesn't exist. And so it's like a shortcut through all that almost. It only really works for strings, and it's not very safe. Like, don't use it to actually encode things, but but it's good for like little funny things like all this stuff.
Okay, cool.
Yeah, but then so you have the code table, and then you could assign like the whatever text phrase. I assigned it to a variable, but then you just use .translate and the code table. You put it in there, and then it translates the word. But
Nice.
you could also use MakeTrans to encode all your stuff. So what I just did was I reversed this for that and put that in there, and then just use the dot lower. So it doesn't matter if everything's uppercase, lowercase. It all gets encoded just the same.
Nice.
Yeah. I thought it was pretty nifty because MakeTrans saved so much time.
Yeah, it definitely does.
Yeah.
I'd forgotten about that MakeTrans.
Yeah. I was looking at the when I was reading through the challenge, I had initially thought of for loops and the using the ORD function and all that other stuff, but then I was like, wait a second, let me try out MakeTrans. But yeah, that's oops. Okay.
Nice.
Yep. Yeah.
Good work.
Thanks.
All right. So, up for tonight. I didn't have too much planned. If you guys want to have a discussion or Q&A, or if you want to do some live coding, I'm up for any of those things. But I'll leave it up to you.
Live coding sounds good.
I can do live coding. All right. Sounds good. Let me set up the presentation mode. We'll take a look at Reddit. Was it daily programming? Unicode Chess. Alright, this looks a little confusing. Let's see what's going on here. Generate a chessboard. Okay, so this is alternating black and white squares for a chessboard with the numbers and the letters for the different spaces. Okay. Modified Fenn. Oh. Rook, knight, bishop, queen, king, bishop, knight, rook. And then pawns. And then I don't know what that is. Maybe blank rows? And then pawns for the other side, and then, okay, so that's the starting. Okay, it's a simplified ASCII representation of a starting chess position. Lowercase are black pieces, uppercase are white. Numbers are consecutive empty squares. And the slashes are row separators. A modified Fenn notation replaces rooks with S. If the rooks are eligible to castle, they have never moved from the start of the game. And their king has also never moved. A G piece is a ghost, which can be used to invoke two special chess rules. pawn that moves 2 squares can still be captured on the next move by another pawn on a ghost square that he would not have been on if he just moved 1 square instead of 2. Okay. And a king moves 2 squares through castling can still be captured on the next move by any piece on the ghost square that he would have been on if he'd moved just 1 square instead of 2. While such a castle is an illegal move in official chess, for a computer it may be easier to declare the move illegal after the king is captured on the next move. Modified fen starting input position. After the, okay, so this, the pawn has moved to this position, so it's not here. Output 2 and input to 3. Whoa. You can actually put little chess pieces? That's crazy. Edit. Hannah book. Doesn't like the size of empty squares. There's a Unicode pattern. Challenge. Move a few pieces, updating the board. Erase from position. Add empty square color. Add from position. Erase whatever was on the... What?
I don't know the first thing about chess. Let me just get that out the way.
I'm kind of confused here too. I gotta admit. I get that they want to display a chessboard. Let's see if there's another one that makes more sense. One that we haven't done. I'm looking at the easy here. What is square spirals? Take a square grid and put a cross on the center point like this. Okay. The grid, well, the grid is 5 by 5 and the cross indicates point 1. Let's call the top left corner location 1, 1. So top left, that's this one. So the center point is location 3, 3, which is here. Okay. Now place another cross to the right and trace the path. Okay, so you put a dash between them and you put that there. This second point, point 2, is now at location 4, 3. If you continually move around anti-clockwise as much as you can from this point, you will form a square spiral, as the diagram shows the beginning of. What did I do? The challenge today is to do 2 things. Convert a point number to its location on the spiral, and vice versa. Does that make sense? Convert a point number. Oh, okay. So like you'd say 0.4 would be this one. 0.5 would be this one. 0.6 would be that one. 0.7 would be that one. And vice versa. So if you're given, say, 4.3, you'd return 4.2. Does that make sense, or should we keep looking?
I say keep looking, but I don't get the point. No, because I mean like I understand the location, I get that, but what are they talking about when they say the point? Oh, the second point is the.
I think they just mean the order.
Right. Okay.
Like as you go out, but yeah, I'm with you. Let's look again. Shuffling a list, that would be easy. There's a shuffle function. Oh, okay. It says don't use Python's shuffle. All right. This looks interesting. So if we're not using shuffle, it's saying to create an algorithm to scramble the items in an array, let's just say. So given an array, reorder the elements in the array without using shuffle. I think that's how I'm reading this. And if not, then I think it's a good enough exercise anyway. Maybe like a code kata. Does that sound good?
Sounds
Yeah.
good.
Cool. Okay, so let's say input equals, we'll use numbers because that's easiest. 4, 5, 6, 7, 8, 9, 0.
Gotcha.
So then output equals shuffle it. Input, or we're not going to call it input because that's a reserved word. We'll call this okay, and then we'll just go ahead and print if all works well, this should just print out unshuffled, just the values that got in. I'm using Python 3, so I would need to Python 3 shuffle. And okay, there we go. That's our starting point. We have an array. It's passed to a function. We get the result from that function. Actually, let's do something else instead. We'll shuffle it in place, like the shuffle function does. So make this a pass. Let's do that. So it's not making a new list. It's just modifying the locations of the items in the list. So obviously the easy answer that we aren't going to use would be import random and then shuffle. If I'm doing this correctly, if not. For some of the built-in methods, okay, yeah, there it is. Some of the built-in modules that you reference with the objects notation, the dot notation, are the ones you don't. But I think most of them you don't if you do it with the from syntax. Anyway, in any case, this is what we're trying to emulate. Let's call this cheating And then we're trying to do that without a shuffle. So, any ideas on how best to shuffle this array?
Could you just do just the random?
Okay, so maybe like make a copy of the list, or like pop off an element of the list and put it in a random place, or like
Couldn't you just call like the random, like random dot values? I mean, like values dot random.
yeah, so like a random element in that.
Right. Yeah.
Yeah. That's what, rand range?
Right. Yeah. Rand range would be for like 1 through.
So like maybe let's just try taking the first element of the list and putting it in a random location, something like that. Or popping it. Let's pop an element off and then put it back in at a random location. I think that's what you're saying. So then item equals values dot pop. And we'll just print item just to make sure we're doing this right. So it popped off the 0, and then we'll return in the values. And if we do it again, it does it again.
Mm-hmm.
So we got an item out, and now we want to put it back in, but we want to put it back in at a random location. Let's look. Is there a like an insert function for a list? Insert, there it is. Inserts an item at a given position. The first argument is the index of the element before which to insert. Inserts at the front of the list. A insert len A x is equivalent to append x.
Oh, so it adds it to the end.
Right, because this is the length of the list. So we would, instead of length A, we would want to have it be a rand range from 0 to length A.
Mm-hmm.
Alright, let's give that a shot. So position equals rand range 0 to length values, and then values dot insert position. Yeah. So.
Mm-hmm.
Let's go. Make that a little easier to see. So now it's too large. Okay, there. So it worked. We took the 0 off, and we put it back in at another position. And if we tried again, it was inserted in the first position. If we tried again, it was inserted in the 5th position. The 2nd position. Okay. So potentially, we could do this like shuffling a deck of cards and just repeat that process an arbitrary number of times. and it would shuffle the list, right?
Right.
Yeah, you could probably loop through the original list and what, like append all the things onto a new list if you wanted in random
Ooh.
spots.
And let's try this two different ways then. So, new way. Just want to put this here to remember it. Try that one in a minute.
Mm-hmm.
So 4, X in range 1 to 1. It's an arbitrary number of times. We're gonna shuffle that list. Oh, I did something wrong. What did I do wrong? Oh,
Pop.
this is not here. I'll put that in there. Otherwise, I pulled that 0 once, and then I inserted it in 90 or 100 times. Let's do that again.
Oh, look at that.
Very nice.
That works. Let's start with a larger list. So let's say instead, one to 100. Is range a generator?
In Python 3 it is.
So X range is the non-generated version? Maybe? Fine.
I think if you want the non-generated version, you have to use Python 2.
Okay. Alright, so maybe just instead we'll say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Oh, you probably could have used list comprehension.
Oh, you are absolutely correct. Or instead, list range.
That's even easier. Oh, there you go.
It's odd that 0 would end up here 2 times in a row.
The luck of the draw.
Maybe if we shuffle this instead of 101 times, we shuffle it 1,001 times. Super pseudo random. Alright, so that's still fast enough. Not the efficient way to do it. We'll call that one shuffle it. Now we'll make a new. You shuffle it. And you'd said a 4 item in values. New. take a new list and new list this is going to be similar except equals and range and then at the end we say new list our values equals new list. Is that doing something different? We've got a new list here. We go through each item in our old list. We insert it in a random location in the new list. So with this version, we're only going to iterate the number of items that were in our original list, and they get put into a pseudo-random location in a new list, and then that new list is assigned the old value. But wait, is that going to pass it back? I wonder if that is outside this function, if it's still going to be values, or if it'll be something else. Find out. Oh.
Oop.
So the first time this is rand range 0 to 0. We need to prime it.
No, I think you got to do you can't do a random of the empty list, so you want to do it of the values list.
Yeah.
Okay. So the length of the value list?
Yeah, values.
I think I know what's happening. So what's happening here, we're passing in this list. We're creating a new list, and we're assigning the values from this list into this new list. And in this function, we're assigning this variable values to be this new list, but then when it exits back out of shuffle it, this values is still pointing to the original list. So here, let's see if this is the case. We'll put a print in here. New list. Yeah, see? It is shuffling it.
Yeah.
But once we leave that function, it's no longer shuffled.
Yeah. It just used the first list.
Yep.
I wonder which way would be faster if you had enough numbers.
That's a good question. See if we can break this. We'll, instead of 1001, we'll call this length of values times 10. So for each value in that list, we're going to shuffle 10 times. So if there's only one item, it's 10. If there's 100 items, it shuffles 1,000. Now, let's put 10,000 items in our list.
Oops.
Wow.
So it did it, but there was a little pause. Now with that same, let's see, it has a print already in it, so we don't need to do it outside. That was faster. I don't know if it's as good of a shuffle as it appears to be. Although, you know, a lot of these later ones seem to be in the 9,000s.
Yeah.
8,000s, 7,000s. Don't they seem kind of grouped?
Yeah, they do seem kind of grouped.
Yeah.
Like, you're still finding some 5,000s up here. But they seem like maybe it's... So it's faster, but maybe it's not as random as it could be. Because, like, all of those are in the 9,000 range, which doesn't seem right.
Yeah, no, the first shuffle it function, it definitely shuffles it better.
It does shuffle it better.
Yeah.
Well, the first one is shuffling it multiple times. The
Right.
second one is just one time.
Yeah.
Correct. Absolutely. Let's try. I want to try one more time. This time, I want to try it as a generator. Okay, so this one is going to work a little differently. This one is going to for item in shuffle it gen print item. And let's see, for X in values. Should put them out in order as a generator. I'm doing it right. Okay. Right. We'll go ahead and say n equals. That should be concept rated. All in order as a generator. Okay. So now, right now it's just going through the list in order. Instead, let's pick a random item from the list. And I don't want to use choose because I think that's kind of cheating too. How would we pick a random item from the list?
Well, the list is indexed, isn't it? You could probably do that.
Yes. So like so really in so you're thinking maybe something like this. Wow. Then values greater than or equal to 0. That equals thought I was onto something. Okay, so we remove an item from the list each time. It's a random. Let's just say it is. We're just going to pop an item from the list for now. So item equals values.pop. We can say x equals values.pop. Okay, so we know the length of the lists, but we don't need to. So while the list has items, take an item from the list and give it back.
So it should print everything out.
Right now it should print everything out in order. Pop from an empty list. So I want to take out this. Yes. So it prints out everything in the list in reverse order. Now instead of pop, we want to do the same thing but from a random location. List. Remove. Oh, whose value is x. No, that's not what we want. We want position.
I think you could, if you look at list.pop, I think you could use it the index.
You are absolutely correct. That is, I think, what we need to do. So command range 0 to length values. Yes. No. So I'm missing a. There we go. And it seems random. A lot more random than that other one that we had.
Yeah.
And it's fast. There's 3 different ways you could do it. All of them work. Little documentation on here. 1, shuffle it 2, and shuffle it. So shuffle it 1. This version takes the last value from the list and inserts it back in to a random location and performed repeatedly. So what we're doing here. Check the list in Python without using random shuffle. This version, this shuffle will iterate through all items in a list and insert them into a new list at a random location. This shuffle is a generator that will pop an item from a list at a random location. So all items from the list are gone. Okay, so what do we say, just real quick, what do we say about these? So, thoughts. This one seems to shuffle well. Would you agree this one shuffled well, given enough iterations?
Mm-hmm.
Huh? Was that a yes or a no?
Oh, it was a yes.
Okay, cool. Given enough iterations, but can roast. That can grow slow when dealing with large lists. This is the one, this one was faster than the first, but what was the problem with this one?
You had to create a new list on that one.
Yes. Does not shuffle in place. Oh, also, it seems to be somewhat ordered. Thoughts. This one. This one was faster, but also requires an external loop because it also does not shuffle. Cool. Anything else? Any more thoughts on that?
Sounds good.
Sweet. I'll go ahead and push this up to GitHub if anyone wants to take a look at it, or play with it some more later. Sweet. That was fun. All right. Thank you for that. That was enjoyable. Hey, Steve, how's it going? I didn't see you were there because I was not looking at my screen sharing. How are you doing tonight? Okay, might be having some mic troubles there. Well, good to have you. Cool. Well, thanks for going through the live coding. Oh, hello. Still not hearing. All right. Well, good to have you here. I hope that you enjoyed that. Everyone. Anything else you guys wanted to work through or talk about tonight? Cool.
Oh,
Well,
I'm
thanks.
good.
Awesome. Thanks for joining in. Next week's Thanksgiving, so I don't think anyone's going to be here, so we'll wait until the 3rd to meet up again. I hope everyone does have a great 2 weeks. I'll see you all on Slack.
Yes.
And yeah, have a great night. Have a great week. Hope you all have lots of great turkey or what is you. And hey, I'll see you soon.
All right. See you guys.
Yep, have a good one.
Yep. Good night.